I'll wait a little bit and then we start. Okay, good afternoon, good morning, good evening, everybody. Let's get ready to welcome Mrs. Vaish. She is Manager Technology at Hindalco Industries in India, and well, will be introducing herself within the next slides and tell us more about aluminium industry condition-based oil change steps towards lubrication reliability. Please, Aksh, it's yours.
So can I start or we can wait?
No, just start, please.
Okay, thanks, Neil. So thanks for the introduction. I am Akshta Vaish from Hindalco Industries, and I work as a tribology specialist in Hindalco. So today I am here to talk about how in manufacturing industry we are moving towards lubrication reliability with condition-based oil change. So oil means money. Every industry is working hard on decreasing the manufacturing cost and increasing the profits. However, very little attention is paid to lubricants. Even if costly premium lubricant is used, they are often replaced far too early because they have always been changed at fixed interval or because it is recommended by the OEM. Every year, millions and millions of gallons of lubricants are prematurely changed in equipment, resulting in the disposal of oils which still have the remaining useful life. The practice of oil change and equipment repairs done at predetermined levels or intervals without any regard to oil and equipment condition results in the high economic loss to any industry, which in both sides results in also in the disposal of the waste lubricant or also the procurement of the new. So what are the oil changes types? I know there are three types of oil change. One is reactive, second is preventive, and third is proactive or predictive. So which of these type of oil change is the condition-based oil change? So condition-based oil change is a proactive or predictive oil change performed at the right time or for the right reason. Currently, the more progressive industries utilize oil analysis to schedule oil changes, results in the maximization of the equipment life, and a proactive approach in preventing the equipment failure related to the oil quality. So, changing maintenance from reactive to plant is currently the goal of the most of the industries. And oil analysis is used as a tool to monitor oil condition, thereby maximizing oil and equipment. Each of the major tests which are used in the oil analysis will be examined, and the limits, critical or warning limits are provided. So we can establish a baseline on which we can change the oils. So this is why we are saying that it's a condition-based oil change. So how this condition-based oil change works? There are many factors that influence the decision of when to change the oil. First is lubricant volume. If the increase in drain interval saves very little fluid, the time and effort which we spend on the oil analysis is not justified, irrespective of what is the cost of the lubricant. Second is top-up rate. If there is a large top-up is required due to any reason or leakages or any other causes, if top-up is high, then oil change is not required because This top up not only introduces the additives which is required, or also it can dilute the concentration of the contaminant. Third is lubricant cost. Higher the cost, more precise decision is required to save the oil from premature drain. Another is OEM recommendation. Many OEMs have guidelines for when lubricant should be serviced. Because machine operating conditions vary from environment to environment or geographically to geographically. So OEM always give recommendation on the far side. This can sometimes leads to the premature internal based oil change. That's why condition based oil change is more effective when we have more time to monitor the oil. Another factor is oil analysis availability. So in current scenario, maximum industry or companies are using the oil analysis. It's not highly accessible most of the time, like in remote conditions or due to geographical conditions. So when we are not able to analyze the lubes, or it cannot be samples or analyzed, then we have to consider to recommend oil change is condition based oil change to go or not. So the more frequent oil analysis we can perform, the more effective is on condition oil change. Another is cost of failure. For machine that present high downtime cost, combination of condition based and interval based oil change is required, because sometimes if equipment experience the premature failure, or any wrong oil can be used, then in that case, if equipment cost is high, then we have to consider to take in one hand interval based and another hand condition based. Last is the quality of filtration. High quality contamination control improves the opportunity to extend and plan the longer drain interval on the basis of the condition of oil. In contrast of the lubrication, having high contamination due to impression or any poor filtration system, in which a frequent top up is required. So irrespective of the oil change, we are top upping the oil, and it will dilute the fluid properties or degrade the oil. In such cases, the oil change becomes the default maintenance procedure for eradicating the dirt and water from the machine. So what are the benefits of condition-based oil change? First is less need for fresh oil, less refining, less transportation, less carbon footprint, as we are going for sustainable or ESG. So we have to take this approach for any industry. It's important. Second is less reprocessing and disposal of the used oil. And problem in machinery can be identified on the timely based, which reduces the unnecessary maintenance cost. So in current scenario, condition-based oil changes are proving to be very beneficial in long run. It helps reducing downtime, which increases the machine's output and also saves. Now going for aluminium manufacturing process, from which I am presenting this case study. So before going to case study, I want to explain what is the aluminium manufacturing process. So aluminium manufacturing starts from mining. After that, we go for refining, smelting. After that, we produce fabrication products. After that, it's recycled. So we at Hindalco, we are working at the whole level. No field is missed. So like in mining, we have a heavy duty vehicles. In refineries, we have pumps, compressor, digesters, And in the smelting, we have conveyor, gearboxes, downstream also gearboxes, and also to cater all those electricity mixes, we have our own power plants in which turbine, basically steam turbines, are the most critical equipment. So, what are the steps to improve lubrication reliability? We at Hindalco are working on the following steps to improve lubrication reliability, which starts with the selection of the right lubricant. Selection of the lubricant based on the cost and performance, and we may aim for the optimum lubricant best for our equipment. Second is with time lubricant aged due to depletion of additives and exposure to and with time lubricants age due to depletion of additives and exposure to destructive elements also known as contaminants such as heat, air or moisture. So contamination control is the easiest step for us in reliability. Third is we are going to remove the guesswork. Oil analysis is used to optimize the interval and avoid premature disposal of lubricant. And last is reducing leakages. Early address to leakages results in the lubricant saving and also reliability improvement. So at Hindalco, first study which we conducted is in refinery mill gear oil. So we are using 320 grade oil in refineries. So we fixed the limits for oils, which includes viscosity, oil cleanliness, ice code, acidity, and moisture. We give warning range, critical range. Monthly, we start doing the sampling and analysis and start populating the data. For oil conditioning, reconditioning, we use centrifuges and vacuum dehydrators. And we are reconditioning the oil on only those tanks which have the volume greater than 55 gallons. Otherwise, it will not be a feasible solution. So, for those gearbox in which the moisture is high, we are using the vacuum dehydrators and centrifuges to remove the moisture and also again storing in our tanks, in a different tanks. So, in place of the using of new oil, we start using the reconditioned oil in our mills. After checking the data of that reconditioned oil also. So this reserve, because of this oil change with new plus recondition, which is done on the basis of the laboratory data, this results in near about $10,000 saving in 1 year for us in refinery bills. Second study which we conducted in our turbines oil, not is the study currently we are practicing this. So this is on the for the aged lubricant in the place in this study for aged lubricant in place of disposing of all the oil we went for the reconstruction of lubricant by addition of the degraded additives. In Hindalco, we have a 6 steam turbines in one plant, having reservoir size of 11 KL, and life expectancy of oil is near about 10 years. We monthly do the routine test, including ice scores, acidity, viscosity, moistures. Yearly, we conducted a RPOT, emulsivity, and foaming test. So we prepare the warning and critical limits for them. In the routine analysis, when we found what are the gap areas we identified in our additives. We start using the additive package to improve those properties. If in RPOT we find out that in oxidation values the life expectancy is coming as less. With the help of OEM also, we start taking help from them how to reintroduce additives so that to improve the life expectancy. Also in case of foaming, if foaming is tendency is very high, we use the foam additive package to improve the foaming tendency. So by using the quality lubricant, we begin to see the reduction in the overall amount being spent on the oil. So I didn't calculate how much, but now this is our current practice we are following from last 2 years, and the oil life is now very much improved. This is the third case study from our mining sector. So in mining, we are using a lot of heavy duty machineries, so engine oils are used. So the major lubricant which comes in picture in mining is from engine oils. Before oil analysis was performed only after the failure of the engine to measure what is the wear and tear of the engine and how to, like in reactive. And oil change happens at a regular interval at a fixed time without any oil. For changing this trend, we decided to take sample after every 5,000 kilometers until we have data so that we can start preparing what should be the drain interval. After checking all those data, we prepare a drain interval, we establish a drain interval. So on that interval, now we perform the oil analysis and determine is it correct or not. Because of this process, we extended our drain interval from 5,000 to 10,000 kilometers, resulting in the saving of $5,000 per year in one mining. We have a lot of 6 to 7 mining sectors. So now we start implementing this in our all other mining sectors also. So what are the challenges which we faced at Hindalco in this? So we can say condition-based oil change are risky. We know and we also face this. They can help you avoid a lot of cost, but they can also result in the catastrophic failures if it's not done correctly. There were many situations which we faced in which maintenance and reliability are not optimized. So we find out that condition-based oil change required like experience, money, because in this oil analysis is required. So we now established a well set up condition-based oil change program with dedicated team. There are also many risks which we faced or of the running of oil too close to end of life. So this also resulted in the sudden need to change the oil and also wear and damage to the machine. So there are many factors we have to take in consideration for making a call to go for the oil change or not for that equipment. So I already discussed what are the 8 parameters which I followed at Hindalco. So for critical machinery and in cases where the cost of oil change is high, we feel that there is a real need to move towards the condition-based oil change where the benefits outlived the risk and cost. So thank you. This is from my side. This is small case study which I want to show at Hindalco because I know there are lots of things which we grew at industries, but we are not able to represent at a different forum. And in this forum, we have a lot of persons from the solution side, not from the problem side. So thank you all. Thanks, Neil.
Thank you, Aks. Thank you for the good presentation. There is a few remarks that I have basically from many parts around the world. So one comes from Canada, Ahmed Mazar Bazir, enjoying your presentation. Bruno Kaksa, also enjoying your presentation. And Muniver Korkmaz, I think I remember he is from Turkey, I thought, but excuse me if I'm wrong. Um, also enjoying the presentation. I see many things towards you. I think the
Yes, from
presentation.
Turkey.
Yes, from Turkey, indeed. Yes. So yeah, I see no real questions. So I guess that your presentation has been very clear. Um, what I always think about when I think about India is that it's a very big country, and there is a lot of industry going on there, and I think people are not always so much aware of it. So that's always very interesting to hear. When you are not living in your country, when you are just living somewhere else, uh, and yeah, no, thank you very much for this presentation. Um,
Thanks, Neil.
Yeah, as
Thank
I
you
I
all.
don't thank you all. Let me see. Ah, yes, that's a good question from Muniver. Indeed, that was one that, yeah, Muniver is remarking he couldn't see MPC in ruler and ruler
So
results in your
yeah,
presentation.
we
Is
are
that
not
something?
conducting ruler because,
Ah,
but we
okay.
are doing MPC because we have a constraint in India. Ruler is not available. We
And
have to
why?
send our sample outside. I start asking that who can give me the values on ruler. So I have a MPC. So I conducted the test at MPC and in turbines, especially in turbines, and calculated at IE. But we
Mm-hmm.
didn't give the critical limits on MPC because currently our turbines are not very old. That's why I
Okay.
didn't include the data of MPC.
Okay. And you said ruler is not available yet in India, so that's an opportunity for the
I
future.
asked and yeah, in future because it's a very costly test, and I asked 2 and 3 laboratories that who can perform this, but they say we don't have the facility, so
Mm-hmm.
it's tricky to send sample outside.
Yeah. That's a commonly heard remark. Alex, that's true. That's true. Okay. Well, thank you very much. Thank you to the audience for listening in. And yeah, I would say, yeah, Wanda, Wanda is remarking, you can purchase the ruler and standard solution from Fluidtech. Wanda, thank you. That's very true. I think that's definitely true. So,
Yeah, I will
so
explore the possibility.
yes, please do. That's always a great idea. So thank you very much again for presentation. Thank you to the audience, and I will end this session. So thank you, and see
Yeah,
you soon.
thank you.
Thank you. Bye bye.
Bye. Yeah, thanks.